Okay, let us see the introduction of HVDC. In modern DC power transmission is relatively a new technology which made a beginning in the year of 1954. Very first I said to you all, but you didn't seen on my PPT screen. No problem. Let us see the comparison of AC and DC transmission of power. This is this meant by HVDC and HVAC graphical representation. It relatively merits of two modes of transmission. That modes are AC and DC, which need to be considered by a system planner or based on the following factors. Already I told you all that factors are economic of transmission, technical performance, reliability. So economics of power transmission or cost of transmission, insulators, line compensation, cost of compensation, converter and filters. Then economics of power transmission is the cost of transmission line includes the investment and operational cost. The investment includes cost of right of rows, transmission towers, conductors, insulator and terminal equipment. The operational cost include mainly the cost of losses. This is cable of cross-sectional conductor view. The characteristics of the insulator vary the type of voltage applied. For simplicity, if it is assumed that the insulator characteristics are similar for AC and DC and dependent on the peak level of the voltage applied with respect to the ground. All those things mentioned on the cross section of this graphical representation. This implies that for a given power level DC line requires less rho. Already I said rho is right of way. R represent right, O represent off, W represent way. It has to simpler and cheaper tower and reduced conductor and insulation cost. Then the power losses are also reduced, which DC as there are only two conductors. Then it has absence of skin effect with the DC is also beneficial in reducing power loss marginally. Then the dielectric losses in case of power cable is also very less for DC transmission. And the HVDC also having a reduced corona effect tend to be less significant on DC conductor than for AC. And this also leads to the choice of economic size of the conductor with the DC transmission. Other than factors that influence the line cost or the cost of compensation and terminal equipment also, this DC lines do not require compensation, but the terminal equipment costs are increased due to the presence of converter and filter. This is what is HVDC. HVDC having two sides. One is sending end side, another one is receiving end side. Both the sides can taught a direct current without without producing any losses across them. But AC tends to be more economical than DC for a distance less than break even distance and costlier for longer distance. The break even distance can vary from 500 to 800 km in overhead lines depending on the per unit line cost. technical performance of DC is technical performance of DC is the DC transmission has some positive features which are lacking in AC transmission. Because already I told you all, AC has some losses. That losses are corona losses and skin effects, reactive power loss. All those loss are came from AC transmission. So the DC transmission has some positive features which are lacking in AC transmission. These are mainly due to the fast controllability of power in DC lines through converter control. Some following advantages are in that DC lines: full control over power transmitted, the ability to enhance transient and dynamic stability in association AC networks, then fast control to limit fault current in DC lines. These make it feasible to avoid DC breakers in two terminal DC links. Okay. In addition, the DC transmission overcomes some of the problem of AC transmission. That important problems are stability limits, voltage control. So stability limit means the power transfer in AC lines is dependent on the angle difference between the voltage phasor and the two ends. For a given power level, this angle increases with the distance and the maximum power transfer is limited by the consideration of steady state and transient stability. The power capability of the DC line, which is unaffected by the distance of transmission and only it's limited by the current carrying capacity of the conductor, that is thermal limit. Voltage control mean voltage control mean the AC lines is complicated by the line charging and inductive voltage drops. The voltage profile in an AC line is relatively flat only for the fixed level of power transfer corresponding to surge impedance loading. Then the voltage profile varies with the line loading. So many things are connected across the SIL process. That SIL process in the mean of surge impedance loading. The maintenance of constant voltage at the two ends require reactive power control from inductive to capacitive. As the line loading is increased, the reactive power requirement increases with increase in the line length also. Although DC converter station require reactive power related to the line loading, the line itself does not require reactive power. Then the steady state charging current in AC lines. Serious problem in cable, this puts the break even distance for the cable transmission around 40 kilometer. Then HVDC has some advantages, not some advantages, it has more advantages. That advantages are number of applications under cables where high capacitance causes additional AC losses. An example of 250 kilometer cable between Sweden and Germany. Long power transmission without intermediate taps in remote areas. Then power transmission and stabilization between unsynchronized AC distribution system connecting a remote generating plant to the distribution grid. Then it has reducing line cost. That reducing line cost contains Fewer conductor, thinner conductor since HVDC does not suffer from the skin effect. So it has some facilities power transmission between different countries that use of AC and differing voltage and frequencies. Yes, then synchronized AC produced by renewable energy sources. These all are points under the control of HVDC advantages. It's most compact and preferable one. So we suggest this HVDC advantages. Uh, in some more advantages are there: fast power flow control, enhancement of AC system stability, supplying more active power where AC system is at the limit of its short circuit capability. Same like it has some disadvantages. That disadvantages are HVDC or in conversion, switching and control. Then it has some expensive inverters with limited overload capacity. Then higher losses in static inverter at smaller transmission distance. Yes, the cost of the inverter may not be offset by reduction in line construction cost and lower line loss. Finally, the high voltage DC circuit breaker are difficult to build because some mechanism must be included in the circuit breaker to force current to zero. Otherwise, arching and contact wear would be too great to allow reliable switching. Yes, it has some comparison we had seen yesterday class, but a little we have to recall this comparison of HVDC with HVAC. So items or more number of items can have here. That items shown in this table comparatively this item depends HVDC and HVAC power transmission power features are connected here. So kindly look at this. Why HVDC rather than HVAC? Try to understand why HVDC rather than HVAC. This HVDC power transmission is very cheaper in long haul bulk power transmission. It is only asynchronous link, so there is uh, any expenditure to spend for synchronous link. Also accurate control of power flow, both magnitude and direction. Same fault isolation also having. This will be provided improved link stability. So comparatively, HVDC is more preferable for long transmission line. Then this is one example of comparison of right way for 2 GB. Sorry, 2 gigawatt. This is transmission line picture. This transmission line picture having types of DC link, converter station, converter unit, converter transformer, filters, reactive power source, smoothing reactor, DC switching. Okay, this AC lines having 400 to 500 kilovolt, DC line having 400 to 500 kilovolt. Same kilowatt for transmit one end to another end. Okay, this is cost comparison of HVDC and HVAC OHL transmission. Cost wise, most preferable economic status in HVDC system. Then types of HVDC transmission system. HVDC transmission contains five classification. monopolar links, bipolar links, homopolar links, back-to-back links. Multi-terminal links or systems. Both words are same. So let us see monopolar system. This is monopolar system diagram. It use one conductor. Listen carefully. It use only one conductor. The return path is provided by ground or water. Use of this system is mainly due to cost consideration. Then a metallic return may be used where earth resistivity is too high. Example, what? Submarine system. Okay. Next, let us see bipolar system. It uses two conductors, one positive and one negative. Each terminal has two converter of equal rated voltage connected in series on the DC side. The junction between converter is grounded. Then currents in the two poles are equal and there is no ground current. Then one pole is isolated due to fault. Other poles, sorry, other pole can operate with ground and carry half the rated load or more using overload capabilities of its converter line. It has two or more conductor. No, it has only two conductor. Bipolar having only two conductors. Then back to back HVDC transmission line. This back to back line usually bipolar without earth return. This back to back connection always having converter inverter are located at the same place. Then HVDC transmission line is not applicable across the back to back connection because uh, sending end side placed one converter station, receiving side placed one converter station. Both converter station connected anti-parallelly of the short distance. So there is no HVDC transmission line. Provides asynchronous tie between two different AC networks. HVDC does not having synchronous tie. So always HVDC provides asynchronous tie between two different AC network. Power transfer can be either in a direction. This is the picture of back-to-back connection. Then we have to look at multi-terminal system. Yes, multi-terminal system meant by three or more terminal connected in parallel. Some feed power and some receive power from HVDC bus. Also provides interconnection among three or more AC network. This is picture of that multi-terminal system. Okay, thank you.